Hello everybody, my name is Walter and this is the third episode of my Redstone Whistle-Blowing Series. In the previous episode I talked about stage 1 of my realistic bunk elevator, which was the ability to go to the next higher or the next lower floor in this multi-floor elevator. Now it's time for stage 2, which is the call function. Now if you don't know what the call function is, basically if you are not on the floor with the elevator cabin and there is no call function, you're pretty much out of luck. But if there is a call function, all you need to do is activate it and the elevator will come to you. If you are not directly on the next floor, it will also ignore all of the intermediate floors if it's implemented correctly. And once it arrives, well, the doors open and you can get in there, and then now you can go up a layer or down a layer. So that's the call function. Now, as I did in the last episode, I prepared a PowerPoint presentation for the circuitry and my thoughts behind the circuitry to make the explanations a bit easier. But as you also can see, I color-coded the actual circuitry I'm talking about today. So you can follow it. The colors of the wool blocks correspond to the colors I'm using in the circuit schematic I will show you in the presentation. And with that, well, let's actually switch directly into the presentation. And at this point, I would recommend, if you haven't already, to watch the previous episode or you may get a bit confused in the following. Anyway, what were my thoughts about how the call was supposed to work? Well, first of all, I decided to go with a decentralized call function, meaning that I don't have a centralized processing unit somewhere that controls the entire elevator. No, instead I have a call function that is implemented on each floor. So each floor has the capability to send out a call signal. What does the call signal do? Well, I decided the call signal tells the elevator to send the cabin towards you or towards the calling floor, and at the same time to deactivate all other floors. Technically, it would be enough to deactivate all intermediate floors, but it's much easier to say, okay, I'm deactivating all floors except for the calling floor. So the elevator will not stop on some of the intermediate floors. Next, I had to consider when can I actually make a call, and I decided I can only make a call when the elevator is idling on a different floor. Idling means the doors are open and the elevator is standing still. The reason for this is I wanted to make sure that I can only make one call at a time. And there are also some possible problems if I could make a call while the elevator is moving. First of all, if the elevator is moving in the opposite direction, since with a call I'm deactivating all floors, yeah, the elevator wouldn't stop anymore and would just run into the terminal station and remain there, possibly. So that's a problem. The other problem is if the elevator is already moving, that implies that there is a player in there, and the player wants to get somewhere. Now, if I make a call and the elevator suddenly decides to not stop where the player wants to stop, well, you can make friends that way, but some people may be a bit annoyed. So that was one of the issues. Last issue is an edge case. If the elevator is running through a station and it gets triggered at the wrong time, which is just a few seconds or so, or parts of a second, you could confuse the elevator engine and have it somewhat self-destruct or leave the cabin behind or whatever. So to avoid that issue, I can only make a call if the elevator is actually waiting in a station to be called. Next up, obviously I need some kind of trigger, and I'm going with a simple button pressed. Now I already have buttons in my design, which are the buttons to go up a layer or down a layer. And I'm reusing them here, since if the elevator is on a different floor, which is the condition for making a call, I don't need those buttons for anything else. On the other hand, if the elevator is on this floor, I don't need to make a call, so I can reuse the buttons depending on the situation. Next up, I had to consider when does the call actually stop. Obviously, the call stops when we arrive, or when the elevator arrives to be more precise. So when, in this case, the doors open. this should give the player who stands in there enough time to get out, even if another player on another floor immediately makes a call. And a second condition is if a multi-call is detected. Now, a multi-call is a rather dangerous situation with the setup I'm going here, because a multi-call is essentially if you activate a call on different floors at pretty much the same time. There is a small time window where you can make multiple calls. And if that happens, due to the fact that all floors are deactivated except for the calling floor, that ends up with all floors, without exception, being deactivated. Subsequently, the elevator will start in one direction, but it will not stop until it reaches a terminal station, and at that point, the calls will not end, and the elevator is basically dead. So, a very important thing to detect and to resolve in some way. And the last thing I had to figure out is considering the signal lines. I need signal lines between the different floors because now they need to communicate in some way. And I went with a piston, Stein block, redstone block configuration or pillar, which is for one a one-directional system, so I need 2 lines for a bidirectional bus. And secondly, the delays are not symmetric. The retraction of this signal line, which is usually a negative signal or a zero, a logical zero, is instantaneous over the entire length of the bus. The extension has a delay of 1 tick per module or per step. So I had to figure out what makes the most sense, what edge of a signal can I delay a bit, and what edge makes sense to be as fast as possible. And my solution to this, or my thoughts, are the following. I want this time window where I can make a multi-call as small as possible. Subsequently, this time window is the time between starting a call and the elevator starts up on the different floor and the idle signal ends. Subsequently, the call start must be fast and the idle end must be fast. And subsequently correspond to the pistons retracting. On the other hand, the idle start and the end of the call can be delayed a bit. So this can be the piston extension. Subsequently, the call lines use an inverted signal logic. This is not something you will see in the schematic I'm showing you in the following, but this is something that I had to consider when I built my actual circuitry. So if you have watched my Redstone Logic series, you will know inverted logic means ands become ors, and plus or ones become zeros, true becomes false, and so on. But I'm digressing a bit. So that's the logic behind the call. Now, let's quickly recap a bit for what happened in the last episode, or what's important from the last episode for this episode. This is the schematic of the circuit I showed you in the last episode, and here are 3 parts that are pretty important for the functionality of a call. The first part are the internal buses for sending the elevator up or sending the elevator down, which are connected in this case directly to the buttons. Then I have my brakes, which are overwritten if the buttons are pressed or if the internal buses for send up or send down are constantly powered. That is the function I'm using to deactivate an elevator station. And then finally, didn't really need this last time, but now it's becoming quite a bit more important, is the feedback of the system that tells me the doors are open. This is what stops the call or deactivates the ability to make a call in some sense. So that's what happened last. Now, let's look at the new situation. We still have our buttons, we still have our idle signal. I left out the brakes since they are just working in the background. But this time we also have not only our floor, but also the floor below and the floor above to think about. And also the floor below that and above that and so on and so on. So let's say the elevator is currently waiting on my current floor. In that case, the doors are open and I get an idle signal. This idle signal needs to be transmitted to all the other floors. For that, I need my idle line, which is a bidirectional bus, subsequently with 2 signal lines. And all I need to do is simply connect my idle signal onto both lines of the idle line. I'm reusing the signal also at some points in the circuitry, but for now, this is the part I want to talk about. Now let's quickly jump to another floor. Obviously, the elevator is not on this floor, but now we have an idle signal arriving through the idle line. This, independent whether it's coming from above or below, is then reused in the circuitry, but it's also used to light up a redstone lamp which tells the player a call can actually be made. Please note the way the whole signal lines are connected here. I connected it in a way that I don't get any feedback. So if I have a true signal or a power on a blue line, I don't get that power into the green line. That is important to cleanly differentiate between idle signal on this floor or idle signal on a different floor. Very important for the circuitry, as you might remember. Now let's say I want to make a call. Well, as I already said, all I need to do is press the button since I'm reusing them for making a call. So I have some kind of delay due to the internal processing times, and buttons are monostable circuits. Subsequently, since I also don't want to deactivate this floor, and if you remember to the last episode, if I were to give a constant signal on either of the send down or send up internal bus, I would deactivate this floor. So subsequently, I have to work with pulses, which is the reason for this monostable circuit there. I can also make only a call if I get an idle signal from a different floor, which is the green line. Now, since I'm working with pulses, I need some kind of memory circuit because, as you might remember, the call signal needs to be constant and only turned off if the elevator arrives or I detect a multi-call. Subsequently, I need an RS knowledge. This also connects to some part of the circuitry, but also a second redstone lamp, which tells the player, okay, a call was made on this very floor here. This signal then also only ends if the elevator arrives on this floor, the doors open, and this resets the call signal. The call signal needs to be transmitted to the other floors, obviously, through the call line. Here, as I said, the call line itself is actually an inverted logic. I didn't really show you this here, since this would be a bit more complex to display. Just keep this in your mind. This is actually an inverted signal line. And now let's jump back to the floor where the elevator is currently on. Here, I'm taking the signal from the call line and sending it into the internal buses for send down or send up. If I get a call from below, I transmit this into the send down bus, and if I get a call from above, I send this into the send up bus. Pretty standard, and that way I make sure that the elevator actually starts in the correct direction. Once more, I have to make sure that I don't get a feedback, because if I were getting a feedback from my actual call into the calling floor, I would override also the calling floor. So here again, I had to make sure that I have this step in the signal lines and the signal lines connected in a way that I don't get any feedback from my current floor into my current floor. Very important part here. Now, this is the basic functionality, but there is still one very important part missing, and that is the multi-call detection. As I said, multi-call is a big problem because if I have a multi-call on different floors, as you can now see in the circuitry here, if I have a multi-call on different floors, those different floors will basically deactivate all floors. Okay, now how does this look? Well, it's pretty simple. I'm detecting independent of where the call comes from. If a call comes, I send a reset pulse into my call RS knowledge. Pretty straightforward. This means basically if a multi-call is detected, all calls are stopped. That ensures that the elevator will stop on the next floor it arrives at, and I don't have to consider, is the elevator moving away from me, is the elevator moving towards me, which floor has the higher hierarchy or higher priority or whatever. I just stop all calls, since the circuitry obviously is replicated on all different floors. And we're back. So now you should have a rough idea of what the circuitry is supposed to do, and with that, let's actually look at the circuitry and how it's implemented. Now, first of all, as you can see, the circuitry is more or less fused onto the side of the already existing circuitry, which is pretty much what I have shown you in the previous episode. There were just some minor modifications concerning how this circuitry or this redstone line here was running, but there were no function changes. Now, since this is fused in there and a pretty compact circuitry, I copied it once more onto this side without the old circuitry, so you can see a bit better what's going on. Now, first of all, what you can see quite easily is that there are 4 signal lines that connect the different floors and go basically from the very top to the very bottom. Those are the 2 buses, 2 signal lines for the call signal and 2 signal lines for the idle signal. You can also see at the moment the elevator is waiting on this floor here and no call is being made. Subsequently, since I have an inverted logic, both call lines are extended and the idle line is only extended going away from the station where the elevator is on. In the opposite direction, it's not extended. Similarly, if I were to make a call, for example, on this floor, then the lines that get away or leave this floor would also retract, but not the lines that go to this floor. So you can see, basically, if you change the direction, also the line that's extended or retracted also changes. So that's the signal lines. Now let's talk a bit about the idle signal. You can see this piston here with this wheel block, which is pretty much inserted into the already existing circuitry and connected or powered by this line here. This redstone line here is part of the circuitry that opens and closes the door. You can see the door is open and this is not powered and the piston is retracted. Here on this floor, door is closed and the circuitry is powered and the piston is extended. So this is at the moment an inverted idle line. Subsequently, I'm inverting it once more and get a simple idle signal as I have already explained in the circuitry. The idle signal goes onto this line upwards and onto this line downwards. So let me quickly activate it and you can see idle downwards, idle upwards. So those 2 are the idle lines. You can also see already where the signal lines are, or where the inputs from the other floors above and below are collected, which is this floor here, or this redstone wire here. And that actually goes into this piston, which moves this piston below this area here. And this is actually where the RS knowledge comes into play. So this is the RS knowledge for the call. And subsequently, only if this piston has moved this piston over there, I can actually make a call. A call is when this entire thing here is moved upwards. Then, well, if this is moved upwards, the signal here turns off. Again, now we are in an inverted logic. Signal turned off means we have made a call. And that then is directed onto this signal line here and going up a bit in here onto this signal line here. This is basically how a call is made. The call then, yeah, as you notice, I'm basically going in the same order as I went into the schematics. Now, if a call is being made from the outside, this is detected by the removal of this, or the moving of this composter here away from this one here. So if the call comes from below, this torch will turn off, or will turn on, and will activate the send the elevator down line. If the call comes from above, then this one here will be moved behind this one here, behind the comparator. And this block here will be powered. And this block here is just on top of this line here, which is actually the bus line for sending the elevator up. So those are the feedbacks. I almost forgot the resets. So if the door opens, this means this piston here retracts, this piston extends and resets the Ars knowledge. It also works as a bit of an override, so you can make an accidental call. Subsequently, if you are on this floor and you press the button to go up or down, you're not making a call, but you're just sending the elevator in the corresponding direction. So that's that part. And almost the last part, this down here, is how you actually make a call. So it basically starts with this piston here. This piston is hidden down here, and it actually gets activated together with the circuitry or by the circuitry that actually triggers the movement of the engine. So there is a bit of a delay involved, which you have already seen in the schematic, and then the piston extends. This is our monostable circuit from the schematic, and that triggers the Ars knowledge. This here is a little addition I made. This is just, again, more or less a suppression to make sure that I remove or make the time window for a remote call as small as possible. And also I had some issues with signals traveling at strange intervals, and yeah, this was a bit of a late addition to the circuitry, but it's essentially just another little suppression of making a call at the wrong time. And with that, the last part I need to show you is the MultiCore suppression. The MultiCore suppression is this purple circuitry here. And it's also pretty simple. When I get a call through this line, it triggers this observer. When I get a call from this line, it will essentially also trigger this observer down there, this observer here. And well, both go into the same circuitry, which essentially suppresses or resets the Ars knowledge. So basically, pulse here or pulse there goes in there, gives me a pulse into the Ars knowledge. Now the circuitry for the topmost and the bottommost floor obviously looks slightly different. Well, for one, you only have a connection to the floors above or the floors below. And for the other, the actual floors have a different circuitry if you compare them to a two-way station, especially the topmost floor with this flat surface at the top is obviously noticeably different. Nevertheless, the circuitry works pretty much exactly the same. There were some minor modifications. For example, here I went with a dropper monostable, since now I had a lot of space to work with and it fit better into the entire system. And similarly, in the bottommost station, I also have a dropper Ars now, as you can see here. But besides of those minute changes, the circuitry works exactly the same. It follows the same principles, and there are no real functional changes concerning the entire system. And with that, we have reached the end of this episode about the call function of my realistic bunker elevator. Next episode will be about the final stage of this elevator, which is a remote call or level select function. Nevertheless, I hope you enjoyed this little episode, and well, see ya!